So yesterday, what we have covered? Unit number 3, right? That is Verilog modules for the combinational and sequential circuit. Clear? Now, from today, we will start with the next unit, that is unit number 5th, testing of logic circuits. Okay. So yesterday I have clear you, okay, that unit number 4, that is state machines, that we are going to cover at the last. Okay. Now first we will cover the unit number 5th, that is testing of logic circuit. Then we will cover unit number 6, that is architecture of the commercial devices, and at the last we will discuss that unit. Okay, unit number 4, that is state machines, because that is very easy unit. In that you have to again study the Murray machine, right? Mealy state model, Murray state model, and all that. So that thing already you have learned in your digital techniques subject. So again, there will be a repetition of that. So today now we will talk about the testings of logic circuits, that is unit number 5th. Okay. So already we have covered the 3 units, right? Unit number first, that is EDA tool and basics of VHDL programming. Then in unit 2nd, we have actually studied the different combinational and sequential logic designs using VHDL module. Then in unit number 3, same thing we did, right? We have studied the Verilog language. Then again in that also we have studied different sequential and combinational logic designs. Yesterday I have demonstrated you, right, with the help of Xylene project navigator, how to execute different Verilog codes, how to write different sequential and combinational design, all that, right? So that thing we have discussed yesterday. Now today we will discuss about now the testing of logic circuit. Now you can understand one thing, how we are how our syllabus flow is. Now see, at the very start we discussed about the need of EDA tool, right? Then what are different EDA tools available? Then what do you mean by hardware description language, that we have discussed? Then it's 2 types, VHDL and Verilog. So we have studied the 2 types of VHDL HDL language, that is we have studied the VHDL modules as well as Verilog modules, and now we are all aware of the how to write code by using VHDL model as well as by using Verilog model, right? Its syntax is different. Okay, its syntax is different. Now today we will discuss the now the testing methods, because see, you are designing something, right? You are designing particular logic circuit. Doesn't matter whether you are using the VHDL module or Verilog module, no problem. You have designed a particular logic circuit. Fine, that is okay. Now next thing is, we have actually verified that simulation properly by using different test bench. Okay, we have written the test bench code also. We have simulated that circuitry with the help of a VHDL test code. That is also okay. But now the next part, or the next testing term, or the next testing will we have to carry out when actually we will debug that particular VHDL code onto a target hardware, right? Means what? See, म्हणजे आपण काय केलं, आपण एखाद्या लॉजिक सर्किटचा आपण कोड लिहिला, बरोबर? VHDL किंवा Verilog जे काही तुम्हाला सुटेबल असेल त्याच्यात आपण त्याचं सिम्युलेशन करून बघितलं, दॅट इज ऑल्सो ओके, नो प्रॉब्लेम. पण नाउ व्हेन इफ यू मेक अ चिप ऑफ दॅट पर्टिक्युलर पर्टिक्युलर डिझाईन, किंवा त्याचा जर का तुम्ही आयसी किंवा त्याचं जर का चिप बनवली किंवा तो प्रोग्राम जर का तुम्ही सीपीएलडी किंवा एफपीजीए मध्ये जर का तुम्ही तो डिबग केला किंवा बर्न केला, तर आता तो प्रोग्राम हार्डवेअरवर कसा चालतो हे पण तुम्हाला टेस्ट करावं लागणार का नाही लागणार, राईट. सो this unit we will cover that part of the testing, right? Testing of logic circuits, right? Previously तुम्ही म्हणाल मग सर आपण टेस्ट बेंचनी ते टेस्ट केलंय की, ओके. टेस्ट बेंच इज अ सिम्युलेशन. हार्डवेअर होतं का त्याच्यात? नाही. वी हॅव जस्ट सिम्युलेटेड द वेवफॉर्म्स, राईट, विथ डिफरंट स्टिम्युलस. आपण स्टिम्युलस मध्ये जे आपण डिफरंट व्हेरिएबल त्यांनी ते सिम्युलेशन दाखवले की ओके फाईन, ऍट सिम्युलेशन लेवल आवर डिझाईन इज ओके, बट व्हेन we actual debug that or burn that onto a particular target hardware, then how it will work, the question is. बरोबर आहे. एखाद्या पर्टिक्युलर टार्गेट मध्ये आपण जेव्हा तो व्हीएचडीएल कोड जेव्हा आपण बर्न करतो किंवा डिबग करतो, तर तो टार्गेटवर त्या हार्डवेअरवर कसा चालतो हे पण तुम्हाला टेस्ट करावं लागणार का नाही लागणार. अँड दॅट इज व्हॉट टेस्टिंग ऑफ लॉजिक सर्किट्स. क्लिअर दिस थिंग. म्हणजे जेव्हा एखादा तुम्ही व्हीएचडीएल कोड लिहिता, तो टेस्ट बेंचनी व्हेरीफाय करता आणि त्याची एखादा तुम्ही आयसी बनवता किंवा चिप बनवता किंवा तो एखाद्या एफपीजे किंवा सीपीएलडी वर तो तुम्ही कोड बर्न करता, तर देन हाऊ इट विल वर्क्स ऑन दॅट टार्गेट बोर्ड, राईट. किंवा जो तुम्ही जी चिप बनवलेली आहे किंवा ज्या एफपीजे वर तुम्ही तो बर्न केलेला आहे किंवा सीपीएलडी वर बर्न केलेला आहे, मग तो कोड त्या सीपीएलडी किंवा एफपीजे वर पण व्यवस्थित चालतो का नाही यासाठी तुम्हाला तो टार्गेट बोर्ड म्हणजे ते सीपीएलडी एफपीजे किंवा जर का तुम्ही त्याची एक सिस्टीम ऑन चिप बनवली असेल किंवा ऍप्लिकेशन स्पेसिफिक इंटिग्रेटेड सर्किट म्हणजे त्याची एखादी आसिक चिप बनवलेली असेल, ती पण तुम्हाला टेस्ट करावी लागते का नाही, राईट. मग ते हार्डवेअर, ते लॉजिक डिझाईन किंवा लॉजिक सर्किट जे ऍक्च्युअल आता फॉर्म झालेला आहे, तो कोड त्याच्यावर बर्न करून ते लॉजिक सर्किटचं टेस्टिंग म्हणजेच आपण आता या युनिटमध्ये टेस्टिंग ऑफ लॉजिक सर्किट्स आपण पाहिलेलं आहे. आपण टेस्ट बेंच लिहितो म्हणजे वी आर जस्ट सिम्युलेटिंग दॅट वन, राईट. We are just simulating that part, right? And also we are checking the functionality, but in simulation no hardware is involved there. Hardware आहे का त्याच्यात? नाही. फक्त we are simulating that part. Whether hardware is involved in simulation? No, not at all. फक्त तो कोड तुम्हाला सिम्युलेट होतोय, पण तो हार्डवेअर वर बर्न केल्यानंतर तिथं व्यवस्थित चालतोय का नाही हे कोण चेक करणार. त्यासाठी we have some methods, right, to check sequential circuits, to check combinational circuits, right. And in this unit now we are going to discuss about that testing of logic circuits. म्हणजे जी तुम्ही तुमचा डिझाईन केल्यानंतर जे तुम्ही हार्डवेअर फॉर्म करणार आहात, जो काही तुमचा एफपीजीए सीपीएलडी किंवा तुम्ही आसिक जी तुम्ही फॉर्म केलेली असेल, आता ती चेक करायची आहे तुम्हाला. अँड दॅट इज नथिंग बट टेस्टिंग ऑफ लॉजिक सर्किट्स. समजलंय सगळ्यांना? ऑल ऑफ यू गेटिंग माय पॉइंट?
येस.
Okay, fine. Now, first we will talk about the need of testing circuit, right? Why we have to test that particular hardware or that logic circuit. So we will talk about that. So there are actually several reasons that we should go for the testing of logic circuit. First one is, when the circuit is first developed, it is necessary to verify that the design circuit meets the required functional and timing specification. म्हणजे ज्यासाठी तुम्ही कोड लिहिलेला आहे, बरोबर आहे, ते हार्डवेअर किंवा ते सर्किट तसंच वर्क होतंय का नाही, बरोबर आहे, हे तुम्हाला चेक करावं लागतं. ते कसं चेक करणार? You have to check that actually hardware part. You have to test that circuitry. Then and then only you will come to know whether it meets the required functionality or it is not meets that required functionality or it is not meeting that required functionalities. म्हणजे ज्यासाठी ते बनवलंय ते व्हायला पाहिजे का नको त्याच्यात, का काहीतरी तिसरेच रिझल्ट येत असतील तर डिझाईन इज रॉंग or hardware is faulty. You can conclude that, right? So this is the first purpose. Then the second purpose is when you have to produce the multiple copies, right, or when you have to manufacture the multiple copies of that particular chip or IC, it is essential to test each copy to ensure that manufacturing process has not introduced any flaws. बरोबर आहे. आता ओके, तुम्ही एक डिझाईन बनवलं बरोबर आहे. Now you have to manufacture the multiple copies of that particular hardware or particular logic circuit. Now you have to test each and every circuitry to ensure that there is a flawless manufacturing process. There is a flawless manufacturing process. नाहीतर एक बरोबर यायचा किंवा 2-4 बरोबर यायचे, परत 2-4 चुकायचे, असं नको व्हायला. We want our every manufactured hardware that's to be a flawless. बरोबर आहे. जी काय जेवढ्या काय तुम्ही आयसी किंवा चिप किंवा जे काय हार्डवेअर तुम्ही मॅन्युफॅक्चर करणार आहात ते सगळे इंडिव्हिज्युअल युनिट हॅज टू बी अ फ्लॉलेस. फॉर दॅट पर्पज अगेन यू हॅव टू कॅरी आउट द टेस्टिंग ऑफ दॅट लॉजिक सर्किट इंडिव्हिज्युअली. बरोबर आहे. नाहीतर सपोज तुम्हाला 5 आयसी घ्यायचे, त्यातले 2च चालतात आणि 3 चालत नाही. ह्याचा अर्थ काय की ते 3 आयसी चेकच झालेले नाहीयेत. तसं करून चालणार आहे का? नाही. आपण जेवढे कॉपीज मॅन्युफॅक्चर करतोय त्यातली प्रत्येक आयसी किंवा प्रत्येक चिप ही चालली पाहिजे, म्हणजे त्याच्यात कुठली एरर किंवा फॉल्ट नको आहे. मग त्यासाठी तुम्हाला यू हॅव टू चेक इंडिव्हिज्युअल चिप और इंडिव्हिज्युअल आयसी right after manufacturing, and for that purpose also this testing of that logical circuit is very essential. Now next issue is the basic of all testing techniques is to apply predefined set of inputs called test to a circuit and compare the outputs observed with the patterns that a correctly functioning circuit is supposed to produce. बरोबर आहे. मग हे कसं कॅरीड आउट केलं जातं? So for that you have to first define or you have to first make a set of that predefined test inputs. बरोबर आहे. ते टेस्ट करण्यासाठी तुम्हाला काहीतरी प्रीडिफाईन्ड टेस्ट इनपुट बनवावे लागणार आहेत त्याची, राईट. सो यू हॅव दॅट प्रीडिफाईन्ड what we can say input set, or you can see that as a test vectors or test input, and you have to apply that test vector to that individual circuit and you have to observe the pattern or outputs, and then you can decide whether that is correct one or that is wrong one. बरोबर आहे. For example, I have manufactured the AND gate IC. A simple example we will consider. Okay, I have manufactured the AND gate IC. Okay, I have designed its VHDL code. I have simulated that, right? I have implemented on a particular chip and I have manufactured the AND gate chip or IC, you can say, right? Now I have to check that AND gate IC. बरोबर आहे. मग तुम्ही कशी चेक करणार AND gate IC? So all of you are aware of suppose it's a 8 input AND gate IC. बरोबर आहे. 8 इनपुट त्याला देता येतात AND gate IC ला, right? And accordingly it will generate the output. Now all of you are aware of the property of AND gate, that if all input is 1 then and then only output is 1. माहिती का नाही AND गेटचं? AND गेटचं आउटपुट 1 कधी येतं? जेव्हा दोन्ही इनपुट 1 असतील तेव्हाच 1 येतं का नाही? का नाही येत?
येस सर.
हा, मग मी टेस्ट सेट काय लिहिणार की इफ आय हॅव अप्लाइड लॉजिक 1 to all its input and then I will observe the output, and if I will get that also logic 1 value, then I will say there is a proper functioning of that AND gate IC. बरोबर आहे. Similarly, I have to write such a different test vectors. Now, for example, in case of all zeros, the output should be 0. So this is the second test set. Now I will design the third test set. Now what I will do, I will give logic 1 input to the 4 pins, and for remaining 4 pins I will give the logic 0. Now what output you are expecting? Again 0, right? Again you are expecting 0. Now such a different test vectors or test set I will predefine, right? And फॉर इंडिव्हिज्युअल टेस्ट वेक्टर म्हणजे बरोबर आहे. म्हणजे पहिला टेस्ट सेट काय झाला, आम्ही पहिले आपल्याकडे 8 इनपुटचा AND गेट IC, आपण मॅन्युफॅक्चर केलेलं आहे, बरोबर आहे. आता आपल्याला ते सर्किट टेस्ट करायचंय. मग आपण पहिला टेस्ट वेक्टर किंवा त्याला टेस्ट सेट म्हणणार, तो बनवणार. काय बनवणार? आपण 8ही इनपुटला लॉजिक 1 इनपुट देणार. दॅट इज द फर्स्ट टेस्ट वेक्टर. सेकंड टेस्ट वेक्टर विल बी ऑल झिरोज वी विल अप्लाय. 8च्या 8 पिनला आपण 0 लॉजिक 0 इनपुट देणार आणि आपण आउटपुट चेक करणार. दिस इज द सेकंड टेस्ट वेक्टर ऑर टेस्ट सेट. टेस्ट वेक्टर आणि टेस्ट सेट एकच, त्याच्यात कन्फ्युज होऊ नका. राईट. नाउ वी विल हॅव द थर्ड टेस्ट सेट. इन दॅट we have given the logic 1 input to the 4 pins and logic 0 to the remaining 4 pins, and now I will observe the output pattern or output. बरोबर आहे. Likewise, you can design such a n number of test sets and you can apply to that particular IC and you can observe the output. And if for all test set you are getting the correct output or correct whatever input depending upon whatever the test sets you are giving at all, whenever you are applying the all test sets and for all test sets you are getting the corrected output, then you can say the design or the working of that IC is perfect or there is no fault in that IC. बरोबर आहे. मग असे तुम्ही किती टेस्ट सेट देऊ शकता and you have to check the output. You have to check the output pattern. And for all test set, if you are getting the proper output or the expected output, then you can say that manufactured IC is faultless or flawless and it is working properly. Clear with this? So these are the some of the points. That's why we should go for the testing of logic circuit. Right? First, we have to check the functionality, whether it is functioning properly or there is a malfunctioning, right? Then timing specifications we have to check, right? Then if you want to manufacture the multiple copies of that, then also you have to go for testing. So these are the reasons, right? That's why we have to go for the testings of logic circuit. That's why we have to go for the testings of logic circuit. And how to carry out that testing? You have to define some predefined test sets, right? Apply that test sets to your particular hardware that you have manufactured and check the output, right? For all test sets, you are getting the correct output, then design and the manufactured hardware is faultless. That means correct. There is no fault. And if you are not getting the expected output, that means there is a fault in design or in manufactured process, right? So there is a fault in design or there is a fault in manufactured process, and that's why that hardware is faulty, so that you cannot give it to the customer, right? So these are the reasons that we should or one should go for the testings of logic circuit. Clear with this? Now we will discuss about the testing techniques, right? We will discuss about the testing techniques. So we have two types of logic circuits available with us. First one is a combinational logic circuit we can design. Second one is a sequential logic circuit that we can design, right? That means we have two different categories of logic circuit, right? First may be the combinational circuit and second may be the sequential circuit, depending upon what design you have prepared. So we have different testing methods for the combinational circuit. We have different testing methods for the sequential circuit. बरोबर आहे. कॉम्बिनेशनल आणि सिक्वेन्शियल दोन प्रकारचे आपल्याकडे सर्किट लॉजिक सर्किट आहेत. मग कॉम्बिनेशनल सर्किट टेस्ट करायच्या वेगळ्या मेथड्स आहेत, सिक्वेन्शियल सर्किट टेस्ट करायच्या वेगळ्या मेथड्स आहेत, राईट. मग त्या कुठल्या? तर कॉम्बिनेशनल सर्किट टेस्ट करण्यासाठीच्या मेथड कुठल्या आहेत? फर्स्ट इज अ फॉल्ट मॉडेलिंग और फॉल्ट मॉडेल, देन second one is a path sensitizing, and third one is a random test. So these are the three techniques or method that you can use to test the combinational circuits. And what about the sequential circuits? Now we have again three methods, right? Actually, in that second method, we have many sub methods, right? But at broad level, we have only three levels. First one is a scan part test. Second one is a built-in self test, and last one is a boundary scan test. That built-in logic block observer and signature analysis is a what we can say part of that built-in self test. Okay, but in general, we have three methods to test the sequential circuits. First one is a scan path, second one is a built-in self test, and third one is a boundary scan test. Third one is a boundary scan test. Clear? Now we will discuss the first method of combinational logic circuit testing, that is fault model. Right. Now, what do you mean by this fault model? So, in this method, what we supposed to do, we have to manually create some fault. Right. We have to manually create some fault and we have to check the output. Right. We have to manually create some fault. That means you have to either connect a particular pin to logic 1 or logic 0, or you can say high voltage, or to a ground, and you have to check the functionality of entire circuit or entire design. Right. Then this fault, right, as we have created it manually, we are knowing the output of that circuit. बरोबर आहे. फॉर एक्झाम्पल आपण फॉल्ट आपणच क्रिएट केलेला आहे, त्यामुळे त्याचं एक्सपेक्टेड आउटपुट काय असणार आहे हे पण तुम्हाला माहित असणार की नाही. बरोबर आहे. सपोज यू हॅव इन्सर्टेड दॅट फॉल्ट मॅन्युअली, सो यू आर नोईंग द एक्सपेक्टेड आउटपुट ऑल्सो, अँड दॅट यू हॅव टू कम्पेअर विथ द ऍक्च्युअल आउटपुट. बरोबर आहे. दॅट यू हॅव टू कम्पेअर विथ द ऍक्च्युअल आउटपुट. दॅट मीन्स you have to create the fault manually. As you are creating the fault manually, you are knowing the expected output, right? Then you can compare that expected output with the actual output, means whatever actually you are getting, right? Whether you have created the manual fault. So in this way, you can go for this fault model testing, right? You can go for this fault model testing. And what are the what are the different cases that occurs in this fault model testing? So the transistor switch can be break, or it may got damaged permanently. This is one of the reason. Then wires in the circuitry can be shorted to VDD or to ground, or it simply be broken, right? So this may be the reason. Then there may be a unwanted connection between two wires. बरोबर आहे. दोन जे पाथ असतात ते नको असताना एकमेकात कनेक्ट होऊ शकतात किंवा शॉर्ट होऊ शकतात. राईट. सो these are the different causes of faults, that these are the different probable faults that can happen in the circuit, and this can be tested by using this fault model. This can be tested by using this fault model. बरोबर आहे. ट्रान्झिस्टर ब्रेक होऊ शकतो. बरोबर आहे. परमनंटली डॅमेज होऊ शकतो ट्रान्झिस्टरचा स्विच, किंवा एखादं वायर ही परमनंटली व्हीडीडी ला किंवा ग्राउंडला कनेक्ट झालेली असू शकते चुकून, किंवा एखादा पाथ एकमेकात दोन पाथ अनवॉन्टेड कनेक्शन झालेलं असू शकतं, शॉर्ट झालेले असू शकतात. बरोबर आहे. मग हे सगळं टेस्ट करण्यासाठी यू हॅव टू गो फॉर द फॉल्ट मॉडेल, राईट? Now, how to carry out this fault model testing? Now this is the circuit. Consider you have this circuit with you. बरोबर. हे एक लॉजिक डिझाइन तुमच्याकडे आहे. कसं चेक करणार आहात हे तुम्ही? Now see W1, W2, W3. These are the three inputs. म्हणजे इथे तुम्हाला तुमचे टेस्ट सेट्स जे तुम्ही डिफाइन केलेले आहेत ते तुम्हाला अप्लाय करायचे. And A, B, C, D, and F, these are the fault models or fault wires. These are the interconnected wires in that circuitry, right? That means the fault can occur in any of the wire. Fault can occur in any of the wire, right? Now how to test that? You have to design different test sets, as you can see on the that table. First test vector is all 0, right? First test vector is all 0. Now what we have done here, now we have to connect that individual wire, that means A, B, C, D, F, to either in first case you have to connect that individual wire to logic 0, then connect that individual wire to a logic 1 and test the and check the output. That means first that A wire you have to connect permanently to the logic 0, right? Then permanently to the logic 1, permanently to the logic 1, and you have to check the output. Similarly, in the that B wire, you have to connect that B wire to the logic 0 permanently, or to logic 1 permanently, and again you have to check the output. Similarly, that C wire, you have to connect that to a permanently to a logic 0 for the testing purpose, then connect that to a logic 1, right? The apply the test sets and check the output. Right? Now again, same you have to do with that D port or D wire. Connect that D wire to the logic 0, right? A wire, D wire to logic 1, right? And check the output. And also with that output wire F also, you have to connect that with logic 0, apply that test sets, check the required output, again connect that to the logic 1, then apply that test sets, check the output. In this way, you can find a fault in any of the wire that is present. Fault in the any of the wire that is present in the circuit, right? So in this way you can carry out this fault model test, right? In this way you can carry out the fault model test. That means now consider the example. If that D wire is connected to a logic 0, means permanently you have connected it to a ground. Now which fault it will get detected, right? When you are applying the 0-1-1 test, 0-1-1 test you are applying to that particular model, 0-1-1. But now which fault now you can detect it, whether when for the W2 and W2 it is 1-1, that is 1 ANDed with 1, that is 1 ANDed with 1. What output you are expecting? 0, right? Output you are expecting 0. But now that D part is already connected to that logic 0 ground. That means it will not pass that expected output to that D wire, because we have manually connected the D wire to the logic 0. We have connected that D wire to the logic 0, and now we are checking the output. So in that case, you will not get the proper output. In this way, you can go for stacked model checking, right? Similar thing you can apply to any circuit. Similar way you can apply to any circuit, any logic circuit, right? How to carry it out? You have to prepare first test bench. Now every wire within that circuit, first you have to connect that to a logic 0 or logic 1, check the output. Then consider the second wire, connect that to a logic 1, logic 0, check the output. In this way, you can detect different faults. In this way, you can detect different faults in that circuit. So this is the stacked model method. This is the stacked model method. Okay. Now, next method of the combinational logic testing is a path sensitization. Right? Next method is path sensitization. Okay. Now, this method we will discuss in next lecture. Okay. Today we will stop here. This path sensitization method we will discuss in next unit. Today we will stop here. Okay. Now, if you have any doubt, right, related to today's lecture, you can free to ask. If you have any doubt, you can ask me right now.
सर ते स्टकॅट मॉडेलचं अजून एक एक्झाम्पल घेऊन सांगा ना.
Okay, you want me to repeat this stacked fault model?
येस सर.
हे बघा, कुठलंही जेव्हा सर्किट टेस्ट करता, स्टकॅट फॉल्टचं टेस्टिंग करायचं कसं? फर्स्ट यू हॅव टू क्रिएट द टेस्ट सेट्स बनवायचे त्याचे. फॉर एक्झाम्पल, इथे किती इनपुट्स आहेत? 3 इनपुट आहेत, बरोबर आहे. 3 इनपुटचे किती प्रोबॅबल टेस्ट सेट्स येणार, किंवा किती प्रोबॅबल टेस्ट सेट्स म्हणजे काय? शेवट तुम्हाला बिट्स त्याचे बनवायचे. 2⁻3. हाऊ मेनी कॉम्बिनेशन्स विल बी देअर? 8. सो यू हॅव प्रोबॅबल 8 टेस्ट सेट्स. दिसतात का तुम्हाला 8 टेस्ट सेट्स इथं? 0 0 0 2 1 1 1. वी हॅव 8 टेस्ट सेट्स, बरोबर आहे. फॉर एक्झाम्पल, इफ युअर सर्किट हॅव 4 inputs, how many probable test vectors you can give? 2⁻4. Suppose your circuit have 4 inputs, 4 input terminals. That means you can have W1, W2, W3, W3, W4. That means 4 test bits you can apply. Now, how many combinations of these 4 bits you can have?
16.
16 combinations, right? Starting from 0 0 0 0 to 1 1 1 1. Barabar hai? This is the first step, right? So, depending upon your output, you have to generate the test sets or test vectors, right? Next step. Now, next step, you have to identify the connections between that circuit, right? You have to identify the connections between that circuit. For example, here now you can have the connection from the W1. Okay, we will consider it as an input port. Then W1AF. This is the first path. Okay, or this is the W1AF. This is the first connection, right? That means that internal wire is A. Then next you have to apply the second internal connection, that is B. That is connecting from W2 to that AND gate. So this is the second internal connection. एक कुणाला कनेक्ट करतोय? W1 ला आणि त्या OR गेटला. So this is the first internal wire. Then second one is B W2 to that AND gate. So this is the second connection. Third one is W3 to AND gate, that is C. This is the third connection. मग हे AND गेटचा आउटपुट परत त्या OR गेटला कनेक्ट होतोय. Means there is a one connection, or there should be one connection. So we will take it as a D. And finally, F is the output port, output connection. Means now, second step, you have to identify the internal connections between that circuit. This is the second step. Barabar? And now, how to carry out the testing of that circuit? Now, you have to connect that each and every connection manually to either to a logic 0 or to logic 1. Barabar? You have to consider that is connected permanently to a logic 0 first time, then connect that same pin to the logic you connect that same pin to the logic 1, then check the output. Again come to the second pin. Again, for that second pin you have to follow the same strategy. First, consider it is permanently get damaged and connected to a logic 1, then connected to a logic 0, check the output. Similarly, you have to carry out such a 2 cases, right? To a logic 0 or to logic 1. बरोबर आहे. एक गोष्ट लक्षात घ्या, जेव्हा एखादी वायर डॅमेज होते तेव्हा मॅक्सिमम काय झालेलं असू शकतं? ती शॉर्ट झालेली असू शकते, किंवा ती ब्रेक झालेली असू शकते. ब्रेक झालेली म्हणजे काय? इट इज ओपन सर्किट. किंवा आयदर दॅट विल गेट कनेक्टेड टू अ लॉजिक 1 परमनंटली, एखाद्या त्या हाय व्होल्टेज वायरशी शॉर्ट झालेली असू शकते, किंवा ग्राउंडशी शॉर्ट झालेली असू शकते, किंवा what is the next probability? Either that is connected to a ground or that is connect to your logic 1 किंवा ती शॉर्ट झालेली असू शकते. दीज आर द प्रोबॅबिलिटीज. बरोबर आहे. वायर जेव्हा डॅमेज होते म्हणजे ती काय होते, एकतर ती डिझाईन मध्ये ड्यू टू अ रॉंग मॅन्युफॅक्चरिंग प्रोसेस either that is got connected to a logic 1 permanently, this is the first case, or that is got connected to a logic 0 permanently, this is the second pass. कारण डिजिटल सर्किट मध्ये लॉजिक 1 आणि लॉजिक 2 सोडून दुसरे कुठले व्होल्टेज असतात का? अनालॉग सर्किट मध्ये इंडिव्हिज्युअल आयसी हॅव डिफरंट व्होल्टेज. बरोबर आहे. पण जेव्हा तुम्ही डिजिटल, व्हेन यू आर टॉकिंग अबाउट द डिजिटल सर्किट, either you have a logic 0 that means ground or logic 1 that means 5 volt. बरोबर आहे. दुसरं हे सोडून तिसरं कुठलं व्होल्टेज असतं का तिथं? नाही. त्यामुळे there are only two chances that either that pin got connected to a logic 0 or that pin permanently got connected to a logic 1, right? So in this way you have to test the any circuit. म्हणजे 3 स्टेप. First you have to identify the test vector. How many test vector you will require? Okay, you require a four test vector, W1, W2, W3, W3, W4. These are the four test vector. Then you have to find the probable combinations, right? 2 raised to 4, that will be probable 16 combinations of such a test that you can apply to that circuit. This is the second step. Third step, you have to identify the internal wires or internal connections in that circuit, right? Name it as a B, C, D, E, F, G, H, I, J, K. Okay, maybe anything, right? And now how to carry out the test? For consider the first wire, right? Assume that it got connected to a logic 1, check the output. Now assume that that same wire connected to a logic 0, check the output. This is the first wire. Okay, then come to the second wire, that is B. Then assume that it is got connected to a logic 1 permanently, check the output. Then got connected to a logic 0, check the output. Similarly, the same two cases, that means either logic 0 or logic 1, you have to carry out for the each and every individual internal connection. That means no matter how many will be there, there may be A to Z also, doesn't matter. You have to check such a two cases with individual every pin, and you have to observe the output. And in this way, you have to carry out the testing of that circuit. And this method of carrying out the testing is known as stacked model or fault model testing. One and the same thing. समजले?
हाँ सर.
Okay, fine. So today we will stop here. In tomorrow's lecture, we will discuss about this path sensitizing part. This is the second method of combinational logic circuit testing that we will discuss in tomorrow's lecture. Okay, today we will stop here.